In a multi-phase study, we explore the design potential of unipressure and dual-pressure augmented mice for discrete target selection tasks, and introduce the unipressure click and dual-pressure tap and refine modes of selection. The pressure sensors used in the study report a range of analog values. These values comprise a pressure space of the sensor that can be mapped into a one-dimensional visual space, such as a menu. The pressure space of the sensor is divided into sections, creating targets. The size of targets is determined by the number of available targets in the menu. As you add more targets, all targets become smaller in the pressure space and additionally in the visual space. A pressure cursor shows the currently selected menu item. As you push down on the sensor, the pressure cursor moves down the menu. Continuous visual feedback shows the user how close their pressure level is to adjacent targets. In our first study, we tested 3 different locations for installing pressure sensors. 1 on the left side of the mouse for the thumb, 1 on the top of the mouse for the middle finger, and 1 on the right side for the ring finger. Final selection was controlled by one of 3 selection modes. In click mode, targets are selected by clicking the left mouse button while the desired target is highlighted. In dwell mode, targets are selected by maintaining pressure on the desired target for an interval of 1 second. In quick release mode, targets are selected by highlighting the desired target and quickly releasing pressure from the sensor. We tested subjects with each of the sensor locations and selection modes on menus of 4, 6, 8, 10, and 12 targets. A within-subject analysis revealed that a sensor for the middle finger on the top of the mouse affords the most control of pressure, followed closely by a sensor on the left side for the thumb. Overall, subjects performed best with the click mode of selection. Carrying over the best selection mode and sensor locations from the first study, we performed a second study to compare unipressure augmentation with dual pressure augmentation. We developed 2 novel dual pressure selection modes. The first, called Switch to Refine, is based on breaking up the menu into smaller groups. By applying pressure to the thumb sensor, the user has control over which group of targets is currently highlighted. By applying pressure to the top sensor, the user is locked into the highlighted group. They can now refine their selection, focusing their pressure solely on the top sensor to select the desired target with a left click. In the tap and refine mode of selection, the menu is also broken up into groups. To change which group is highlighted, the user taps one of the pressure sensors. Because there are 2 sensors, control of group selection is bidirectional. Pressure from either sensor refines selection within the group, with a left click controlling final selection. We tested unipressure click, dual pressure switch to refine, and dual pressure tap and refine selection modes with menus of 4, 12, and 16 targets, and also tested switch and tap with menus of 64 targets. A within-subject analysis of the results revealed that unipressure click was the best overall mode for 12 or fewer targets. For menus with more than 12 targets, tap and refine becomes the most effective mode of selection. There are many practical applications for a dual-pressure augmented mouse. Menus for programs can be controlled with the tap and refine mode of selection, allowing the mouse cursor to remain in a contextually relevant location within the document or program, such as when drawing an image in a paint program. Other possible applications include bidirectional zooming with maps, pressure scrolling, and computer games. Dual pressure input would be especially valuable to simulation games where pressure is used in the real world, such as the gas and brake pedals of a car.